Okay, so today we are going to cover the last section of our prerequisite chapter. It's section 5. It's day 4 of section 5. Today we're going to cover rational expressions with complex fractions. So in other words, fractions in a fraction. So we'll have two options on which we can use to solve them. So our first option would be to find the LCD of each fraction, then multiply each term by that LCD, and then simplify. However, I am going to show you in all the examples option 2. And I'm going to find the LCD of the numerator, and then the LCD of the denominator separately, and then I'm going to stay, change, flip, or keep, change, flip, because essentially that fraction bar is the division sign. So let's go ahead and just do a bunch of examples. So for the first one, it's nice and easy. Now, I know it looks kind of strange here, but right here, this is the fraction bar separating the top fraction, which is in the numerator, from the bottom one. Now here, I don't need to add or subtract anything. It's already simplified. So all I'm going to do is turn this into a division problem. So I'm going to do 1 over x. The green bar, that fraction bar, is the division sign, divided by 1 over x squared. So this is just like P5b, and I'm going to keep, change, flip it, or stay, change, change. Keep the first fraction the same, change the division to multiplication, and then flip the second fraction upside down to its reciprocal, and now I'll look for things to simplify before I multiply. I could simplify the x and the x squared. This will become a 1. This will become, I can just get rid of the exponent. And now I'm left with x over 1, which is just x. Okay, example 2. Again, nothing to add or subtract here. All I have is a fraction in my numerator and a fraction in the denominator. Again, that fraction bar is the division sign. So really all I'm doing here is 1 over x minus 2 divided by 1 over x squared minus 4. So now I'm going to first keep, flip, change it. Keep the first fraction the same. Change it to multiplication. And then flip the second fraction upside down, or to its reciprocal. Now it's just like P5b again. I need to factor this first. This is the difference of two squares. So I'm going to go ahead, keep my first one, nothing to factor there. Factor that numerator into an x plus 2, x minus 2, and then it still has the 1 in the bottom. Now I'm going to look for things to simplify. The only thing I can simplify here are the x minus 2's. And now what's left is 1 times the x plus 2, and then 1 times 1 in the bottom, and then that's just a 1. So you could either show that it's x plus 2 over 1, but then you need to simplify it to just the x plus 2. So for example 3, same thing. I've got my main fraction bar here. So all I'm doing here is 1 over x squared minus 9 divided by 1 over x minus 3. I'm just going to do keep, change, flip. So I'll keep the first fraction the same. Change it to multiplication. Flip my second fraction upside down. Now I have to go back and look. Can I factor anything? I can factor this denominator here. This is the difference of two squares. So 1 over x minus 3 and x plus 3. Keep the multiplication there. And this fraction, nothing to factor here. Look for things to simplify. I can simplify the x minus 3's. And now I'm going to multiply what remains. So straight across, 1 times 1 is 1. And then I'm left with x plus 3 times 1, which is just x plus 3. Nothing else simplifies. I'm done. Now here we go, where we actually have to find a common denominator. So this was yesterday's lesson, the adding and subtracting. So really what I'm doing here now is I'm going to do first P5C. I'm going to do the subtraction problems individually. Once I get those simplified, the numerator subtracted, the denominator subtracted, then I'm going to turn it to a division problem and then into a multiplication problem. So really all of P5 all wrapped up into one single problem here. So here we go. Here's my main division. So I need to go ahead and I'm going to work on the numerator first. So I have 2 over x, and I'm going to change the 3 over 1. I need to find a common denominator here. My common denominator is going to be x. So my first fraction is good, but my second fraction, I need to multiply it by x, so it'll get a denominator of x. Remember, whatever you do to the bottom, you got to do to the top. So now my new fraction here for the numerator is going to be 2 minus 3x over x. And now I'll go ahead and do the same thing to the denominator. I have 1 over 1 minus 1 over x minus 1. Remember, I can't just throw in an x or a negative sign. I actually have to multiply to get the common denominator. So my common denominator here is this x minus 1. So I need to multiply the first fraction by x minus 1. So now I'm left with x minus 1 minus 1 over x minus 1. Now I can simplify that blue because minus 1, those are like terms. So now I'm going to go ahead and keep the red still. So 2 minus 3x over x. And then I can simplify the blue, and it becomes x minus 2 over x minus 1. Now I have my division problem. So now I'm going to go ahead and I'm going to do the red, 2 minus 3x over x divided by the blue. Keep change, flip it. Keep the red. Change it to multiplication. Flip the blue. And look for things to cancel. Notice there is no exact matches here. Nothing cancels. So all I'm going to do is write everything side by side. So my final answer here, straight across the top, the 2 minus 3x times the x minus 1 over the x times x minus 2. So then it'll be the x times the x minus 2. Nothing simplifies. That's your final answer. Now, when I post the solution file, or be aware for a PSAT or an SAT, that they might actually multiply it back. For the test, just leave it like this. Don't worry about foiling the numerator. Don't worry about distributing the denominator. But if you see it on the PSAT next month, or maybe in the homework when I post the answers, note that they're going to foil it or they might distribute it. So if I foil the top, so the 2 minus 3x and then the x minus 1, first gives me 2x, outside gives me negative 2, inside gives me negative 3x, and last gives me 3x squared, gives me positive 3x. So then now if I combine these like terms here, then I'm left with, in standard form, negative 3x squared plus 5x minus 2. That's the top foiled. And then if I distribute the bottom, I get x squared minus 2x. So I'm okay with you leaving what I got it boxed in green, or negative 3x squared plus 5x minus 2 over x squared minus 2x. So I'm okay leaving it green, but recognize that these are two equivalent expressions if they were to have multiplied it back. in case you see this on an SAT or the PSAT. Number 5. So again, this is my main fraction bar. So my numerator is the x plus 5, and I'm going to put it over 1. And then my denominator, I need to find a common denominator. So what I need to do here is my common denominator is 5. So I'm going to multiply this one by a 5. So now my new fraction in the bottom is going to be x squared minus 25 over 5. Now that it has a common denominator. So now I'm going to turn it into a division problem. So x plus 5 over 1 divided by x squared minus 25 over 5. I need to change it, change it to multiplication. Now when I go to flip this, I'm going to go ahead and just factor the x squared minus 25. I'm going to make it x plus 5 and x minus 5. I factored this difference of 2 squares, and then I made it this. Let's do it in blue. So this became this. Now I look for things to simplify. I can cancel the x plus 5 and the x plus 5. Nothing else simplifies. So now I'm left with 5 over x minus 5. The 5's do not cancel. Remember, the denominator to the x minus 5 is attached. Do not try to say, cancel those 5's. You will get it wrong. You need an exact match in order to simplify things. So this is your final answer. So for this next one, same thing. Here's my fraction bar. So really all I'm doing here is x squared minus 1 over x divided by x minus 1 squared over x. I'm going to change it. Now, when I go, well, let me do it step by step. Let me just do change it to multiplication, flip upside down, and now I'm going to factor it, and I'm also going to take that binomial squared, and I'm going to write it out 2 times. So right below here is where I'm going to continue working. So I'm going to go ahead and factor this one. It becomes x plus 1, x minus 1 over x. And then this one, I'm going to go ahead and take that binomial squared and write x minus 1 twice. It'll make it easier when I go to look for things to simplify. So now I'm going to look for things to simplify. I can simplify my x's. These both become 1's. And then I can also simplify an x minus 1. So I can simplify this x minus 1 and this x minus 1. And again, what's left behind is a 1. And now I'm going to multiply what's left. I have the blue x plus 1 in the top. And I have the red x minus 1 in the denominator. Nothing cancels here. Remember, it's got to be an exact match to cancel. They're not opposite signs. I can't factor out a -1 GCF. That is your final answer. All right, number 7. All right, this one, I've got to do the 2 problems separately. So I need to subtract the numerator and add the denominator, then I'll turn it to division, then to multiplication. So again, here's my fraction bar. I'm going to go ahead and simplify or subtract the numerator. So I could put a 1 under the 6. Notice my common denominator here is going to be x. So this first fraction, I need to multiply the numerator and the denominator by x. So then now I'm left with 6x minus 5 over the common denominator, which is x. Then for the denominator, same thing. I could put a 1 under the 1, and my LCD is going to be x, so times the top and the bottom by x. And now my new fraction here is going to be x plus 5 over x. Now I have it simplified. I subtracted the numerator, I added the denominator, and now I'm going to turn it to a division problem. So now I'm going to do the red, 6x minus 5 over x divided by x plus 5 over x. I'm going to keep change it. So 6x minus 5 over x, change it to multiplication, flip it upside down. Now I look for things to simplify. The only thing that simplifies here are the x's, and now I'll multiply what remains. So I end up with 6x minus 5 over x plus 5. Again, remember, nothing cancels. Do not be tempted to cancel those 5s. You would need an exact binomial match in order to cancel. So this is your final answer. Next one, same thing. I need to simplify the numerator and simplify the denominator. So this one's a little more complicated. My LCD here of the numerator is going to be a times a plus 1. Remember, you can't just put a plus 1 here. It doesn't work that way for LCD. You actually have to multiply to get an LCD. So now what I'm going to do is the first fraction was missing the a. So I can go ahead and multiply the first fraction by a. And then this becomes a squared. My second fraction was missing the a plus 1. So I'll multiply a plus 1 to here. So 1 times a plus 1 is just a plus 1. So that's my first fraction, or the numerator, simplified. Now I have to do the same thing to the denominator. And the denominator is going to have the same common denominator as that numerator. So here, my denominator of this is also going to be a times a plus 1. So my first fraction here is missing the a plus 1. So 1 times a plus 1 is just a plus 1. And then the second fraction is missing the a. I now need to combine my like terms here on the bottom. The numerator is already simplified. So for my numerator, and let me just write it all in yellow. So my numerator is a squared plus a plus 1 over the a times the a plus 1. And then my denominator is going to simplify into a 2a plus 1 over a times a plus 1. So now I'm going to take the yellow, but I'm going to write it in black so it shows up better. Keep the top, change that green to a division sign. Let's do it in black. And then the blue is the denominator. So I just made it a division problem. That's all I've done. And now I'm going to do keep, change, flip. Keep the first fraction the same. Change it to multiplication. Flip the blue upside down. And now I'll look for things to simplify. So notice the a's simplify. So do the x plus 1s, or the a plus 1s. And now nothing else simplifies. I can't factor that trinomial. So there are no factors of 1 that would give me 1a. So my final answer here is going to be a squared plus a plus 1 over the 2a plus 1. Nothing cancels. I'm done. All right, example 9, same thing. I need to do the subtraction problem in the top first, and then the addition problem in the numerator. So if it helps you to put a 1 underneath the 2, so my LCD here is going to be x. So this one's missing an x. So whatever you multiply the bottom, multiply the top. So this becomes 2x minus 2. I'm going to do the same thing to the denominator. I could put a 1 here. And this one's also missing an x to get the LCD. So 2x plus 2 now. Now that it's simplified and it has a common denominator, we turn it to a division problem. So now I'm really just doing 2x minus 2 over x divided by the yellow, 2x plus 2 over x. Keep, change, flip it. So this becomes keep it, change it to multiplication, and then flip the yellow upside down. Now remember, when you do this multiplication, you need to factor out any GCFs or factor anything. So I can actually factor the numerator here. I can factor out a GCF of 2. Same thing on the yellow. The x stays, but I can factor a GCF out. So now I'll look for things to simplify. So the x's simplify, become 1s, and then the 2's simplify as well. They become 1s. So now my final answer is x minus 1 in the numerator and x plus 1 in the denominator. Do not be tempted to cancel anything, because again, remember these are attached. They are not opposite signs, so I can't even factor out a -1. And one last example. The denominator here is already simplified, but I do need to subtract the numerator first. So my least common denominator of my numerator, this right here, is going to be x times x plus 3. So this fraction here, the first fraction in my numerator, is missing the x. So I'm going to multiply this one by x and x. So then 1 times x is just x. And then I have the minus sign. And then the second fraction is missing the x plus 3. So I have to distribute that subtraction sign into the x minus 3. So now this becomes x minus x plus 3 over x times x plus 3. Now also remember, you still have underneath this the 1 over x. So now, notice when I combine this numerator, x minus x is 0, it's nothing. So now I have 3 over x times x plus 3 over the 1 over x. Now I can finally turn this into my division problem. So I'm going to be dividing 3 over x times x plus 3 divided by, let me use a darker color here, divided by, and I'm going to do the yellow and blue so it shows up. And now I do keep, change, flip. So keep the red, change the division to multiplication and flip the blue upside down. The only thing that cancels here are the x's. So now I'm left with 3, and I think I dropped a negative sign. Oh, looky here. So here, this should have been a plus. And then when I distribute it here, this should have been a negative 3. So this is a negative 3 here. So negative 3 over x plus 3. You could also pull it out in front of the whole fraction. So just be careful, don't drop any signs. Make sure you distribute it to everything. So up here is where this should have been an x plus 3. I wrote the wrong binomial in here, but then when you distribute the subtraction, that's when it became a negative 3. And that is it for the notes on P5D.